All right, in 2.0a, let's look at some line relationships and do some definitions here at the start. So intersecting lines lie in the same plane, and we've had a previous word for that. Remember, a plane is a flat surface that goes on infinitely far in all directions, like the desk, the floor. Anyway, that word is coplanar, okay, that we did last chapter. And then those lines would also intersect. Remember, to draw a plane, we just draw a figure that looks like this so that you know what you might see. And these would be solid lines. Remember, lines have arrows because they go on forever. And you might see something like this. Okay, so if you're imagining that those go on forever, of course, those two lines are going to intersect one another. Now, perpendicular. Remember, the symbol for perpendicular is like an upside down capital T, so you do need to know that. And perpendicular lines lie in the same plane. Again, that word is coplanar. So it could just be saying coplanar and something. So these are coplanar and meet at right angles, because that's what perpendicular means. A picture for this might be there, and then we again would see two lines. And if I just drew this right now, like that is just intersecting. Okay, it has to have a right angle drawn for it to become perpendicular, and so you would have to have that box in there. Okay, all right, so that turns it into perpendicular now. And now let's talk about slopes, okay, because that'll be important for the stuff that we've got coming up. So remember, slopes for perpendicular lines are opposite and reciprocal. Opposite and reciprocal. So let's do a few examples here. If I said one line had a slope of 3/5, then you should know that its opposite reciprocal slope would be opposite sign, and reciprocal means flip the fraction over, so it would be -5/3. If I gave you a slope of -1/2, then the opposite reciprocal slope would be, well, opposite sign would be positive, and that would be 2/1, which is just 2. If I gave you a slope of 4, you need to think in your mind that that is really 4/1, so the opposite would make it -1/4. All right, so keep that in mind for the next stuff. Okay, parallel lines then. Parallel lines, the symbol for parallel, remember, looks something like that. Okay, and then again, our definition will be lie in the same plane. Once again, the word for that, coplanar. And I'll just continue down here. And they never intersect. Okay, lie in the same plane and never intersect. So a drawing for that would be, here we go. So we don't want you ever guessing. Remember, in geometry, we say don't trust what it looks like. Trust what the information is that's given to you. I don't want you thinking, maybe that goes out far enough. Maybe those are intersecting with each other. So we take care of that in this way. So we're going to have another arrow, okay, somewhere in the middle. And I will now highlight that just with a different color on purpose so that you see what I'm talking about. Okay, we're talking about that arrow. If you have arrows on a line, it's going to mean in geometry that those lines are parallel to each other. Okay, and then let's also talk about the slopes while we're here. So the slopes of parallel lines are equal, right? They have the same rise, they have the same run. They're going exactly the same way. And then last but not least, we have skew lines. And skew lines are lines that are not coplanar. Not coplanar. So now they do not lie in the same plane, right? And that we would show like this. Here's a line. Notice it's solid because it's lying in that same plane. And then we have one coming and going through that plane. You would not see that go back behind, and it would come out the other side. Okay, so it's kind of like a dashed line going on there. Okay. All right. Now, you'll remember from Algebra 1 that when two lines intersect, you get a solution to a system. Okay, so the two lines would be the system of equations, and then where they intersect would be their solution to that system. Okay, so coming up quick, we're going to be, again, reviewing a lot and putting our equations into y equals mx plus b form, right? Slope y-intercept form. All right, so let's review this real quickly. Find the slope of each line from last chapter. Remember, your slope is the number in front of x, and your y-intercept is the b. Okay? All right, so here we go. Slope here in A is 2/3. This one in B, not in the right form. So let's manipulate it to make it in the right form. Okay, let's subtract x from both sides. Make that go away. And we would now have 2y equals negative x plus 2, because I'm thinking about putting it in y equals mx plus b form. And then here I'm going to divide by 2, but I've got to divide by 2 everywhere. Okay, and then the 2's would cancel, just leaving me with y equals, if I want a number in front of x, right, for it to be y equals mx plus b, well, you should recognize that this is the same as negative 1/2 times x, right? If you multiplied straight across, you'd have negative x over 2. That's the same thing. Plus 2 over 2 gives us 1. Okay, so now that it's in y equals mx plus b form, you can answer me and tell me that slope equals negative 1/2. Okay, for the question that I was asking you. All right, the next one, slope equals 2, just a number in front of x. The next one, of course, is going to take some manipulation again, right? So we've got 2x, and I want it to say y equals. All right, so if I want it to say y equals, I'm going to target the 3y, that side. Go ahead and get rid of 8 on both sides. Okay, so this is going away. I've got my 3y. On the left, if I want it to look like mx plus b, I'm going to write it as 2x minus 8. Once again, divide everything by 3 to get this to say just y instead of 3y. Okay, simplify one again. Once again, and I would have 2/3 x, right? Because you want the number in front of x to be your slope. So 2/3 x minus 8/3 equals y. And I hope you're comfortable with knowing that that's exactly the same thing as y equals 2/3 x minus 8/3, right? Doesn't matter which side it's sitting on. Okay, either one. But now you should be able to easily read off of there that your slope is 2/3. All right, so good review from last chapter. We'll be using that going ahead. So now, if we're telling if each pair is intersecting, perpendicular, or parallel, it has to do with the slopes. That's why we went through that, okay? So here we're asking you A and B, all right? So we're going to go up here and look at just the A slope, and we're going to look at the B slope, okay, the two that I've starred. Well, if they do not have the same slope, they're not parallel, okay? And so they are going to be lines that intersect. So we're going to say that these lines are intersecting. So no abbreviations, please. Just write out the words intersecting. right? Okay, and now we'll go to B and C. So get rid of some of those. If we go to B and C, all right, so now we're looking at this slope of -1/2 and this slope of 2. And you should recognize that one of them's 2/1 and one of them's -1/2. That sounds like opposite and reciprocal to me, which means they are going to, one, intersect each other, but they're going to intersect each other in a very specific way, and that is perpendicular. So you do need to say both things. You need to say that these are intersecting lines, and they are also perpendicular. Okay, so both. All right, get rid of the stars. Go to the next one. We're looking at A and D. All right, so we're looking at this slope of 2/3 and this slope of 2/3. All right, well, if they have the same slope, then by definition, they are parallel. And if they're parallel, they don't intersect. So parallel is the only answer. Okay, perfect. Get rid of those two stars. And then that last one there, B and D. All right, so we're looking for the slope of -1/2 and a slope of 2/3, right? Flip them over. They're not opposite reciprocals of each other, okay? So they must be just intersecting. All right, and there you go. So using these principles to apply to the next ones, so you already have this written down. These are the same A, B, C, and D above. I'm just going to do a little color coding. If you want to use colored pencils and stuff, you can. All right, but I will just try to stick with the color so that you know which one I am graphing. Okay, so remember, we said a system of equations is if you have two equations, right? Two lines in this case, and you're trying to solve them by graphing them and figuring out where they intersect. Okay, so this first one says graph lines A and B and find the solution to the system. So let's work on line A first, right? So a little review. Our y-intercept would be 0, 1. Okay, so put yourself a big dot at 0, 1. And a slope of 2/3 means up to right 3, or back from the y-intercept down to and left 3. Okay, so there's that line. Remember, you've got a perfect straight edge. It's called your ID. You can do that a lot better in a small circumstance than I can here on the smartboard. Okay, but do your best. Remember arrows because it goes on forever. And then the other one, B, has a y-intercept of 0, 1. Okay, so fill that in. A slope of -1/2 would mean down 1 and right 2. Or back from the y-intercept, it would mean up 1 and left 2. Okay, so again, that should be all review. Connect those the best you can. For credit, you need to remember that when you have a graph with more than one graph on it, you need to go ahead and label them. So let's go ahead and get that done. This, for full credit, is going to be y equals 2/3 x plus 1. So label it. And then the other one is going to be y equals -1/2 x plus 1. And now, where do they intersect? And that one's pretty clear to see that your answer is at the point 0, 1. So it's always going to be an ordered pair, right? So the x value is 0 and the y value is 1 in parentheses. So there's your solution. All right, now they ask us to graph the lines C and D and find the solution. Okay, so for C, y equals 2x minus 4. Let's go to our y-intercept of -4, 0, -4. A slope of 2 is the same as 2/1, which means up to right 1. And I don't want to go off the graph paper, so I'm going to just keep going. Up to right 1 again. Okay, again, do the best you can to make that a straight connected line. You've got your ID. You can do better than I can. Have some arrows on there. I won't label it until I've got the other one drawn. And now, in D, the y-intercept is 0, negative 8/3. Okay, well, some of you might be saying, yeah, I can change negative 8/3 into negative, what? 2 2/3, but that's not going to be very accurate to graph, okay? That's going to be hard to graph. So understand that every line not only has an x-intercept, or not only has a y-intercept, but it also has an x-intercept. So sometimes it's easier to find an x-intercept. So that's the work you're going to see me do here, just to see if it happens to be easier. Okay, so remember, for a y-intercept, you plug 0 in for x. But for an x-intercept, you would plug in 0 for y. Let's say that again. Plug in 0 for y. Okay, so if we do that, I'm going to go back to the original equation. So from the original equation, you'd have 2x equals 3 times 0 plus 8. All right, which would be 3 times 0 is 0. So we're really just looking at 2x equals 8 and x equals 4. All right, so if I plugged in 0 for y and I got 4 for x, that means the ordered pair would be 4 for the x, comma 0 for the y. That looks a lot easier to graph than 0, comma negative 8/3 to me. So I am going to go to 4, 0, which is right here. That's an x-intercept this time. But it doesn't matter. It still has the same slope, right? So if going from that point, I can now say a slope of 2/3 is going to tell me to go up 2 and right 3. Or from that x-intercept, it's going to say down 2, left 3. And I'll do another one, down 2 and left 3. So I've got 4 points on this one. Again, connect that with a nice straight line the best you can, using your straight edge. Extend that a little bit. And now let's go ahead and label them so we don't forget to do that. So we get credit. Y equals 2/3 x minus 8/3. And for the red one, we've got y equals 2x minus 4. All right. And then pretty easy once again to see our intercept and where they intersect, I should be saying. Their intersection point is right here at 1 for the x and negative 2 for the y. So it's an ordered pair, 1, comma, negative 2. So luckily these were nice ones, right? In this first one over here, it's easy to see the 0, 1 where they intersect. And in this second one, it was easy to see the 1, negative 2 where they intersect. But what if it's not nice numbers that they happen to land on? And that's why you have systems of equations, okay? And that's going to be the next thing that you guys are going to be going through and reviewing. But systems of equations can help you to solve them when they're not quite such nice numbers, okay? But keep in mind, it's always from this graph. That's what's happening, is two lines are intersecting each other and they're overlapping. So you're trying to find where they have the same x value and the same y value.